every patch, those test cases are being run, and those stability of each patch, like whatever the code you are merging in any of the projects, that doesn't break your basic functionality, doesn't break your cross-project dependency, so those things will make sure. And we have a lot of tools in OpenStack here. I have categorized into a different category, like on the development and test environment. So this side we have the tooling. You can create your development environment, like DevStack. DevStack is a tool which brings the OpenStack development environment. So it has a set of scripts which install the OpenStack services, and it is a plugin based. So any projects, they can implement the DevStack plugin to get it installed via DevStack. And there are a lot of other plugins for container also, and for set. And this side is the test frameworks. We have the Tempest and the plugins. So Tempest has the set of tests. We'll be talking more in the next slides, and provides the frameworks for Tempest plugin also. We have Grenade and its plugin interface. Grenade is for upgrade testing. So Grenade can test like from the previous release to the current development release, the upgrades are working fine on them. So what basically it does is it installs the previous release via DevStack on a single node, and on the same node it creates some resources like VM, volume, flavors, and then it tries to upgrade the each services with the current master runs, and then check some sanity checks and check the resources created before upgrading the services are present there or not. That is mainly used for the upstream upgrade testing only. And then we have the Petrol. This is the new one for RBAC testing. Like OpenStack provides the APIs with policy control, so where you can define what users and what role has the restriction or the authorization on the policies. So the testing can be done by the Petrol. So this is also the project we will be talking more in next slides. Tempest test is the stress test which used to be inside the Tempest, but we have called it as a separate project. So on this side we have the test results. OpenStack help stack list where you can visualize the result of text in different category, failure, pass, and all. We'll be talking more in next slide. And syntax checking especially used like hacking and basic during the development upstream. You have test runner, S tester, OS tester. S tester is not officially under the OpenStack, but it's like used by Tempest for running the test case. Then we have various other projects here. So out of these projects, we will talk about like what all you can use for your production testing. So I have categorized the 4 projects especially. One is Tempest and its plugin. It's Tempest is the OpenStack integration test suite, so it has the set of tests and the framework to define the Tempest type test. Then we have on the Petrol side RBAC testing, the security validation tool, because each OpenStack services APIs are controlled by the RBAC policy files. So whether they are working fine or not in your cloud, you can test it via Petrol. StackWiz is also visualization utility to help and see like the performance of your test run. And OpenStack Help Dashboard to visualize the result of your CI, your testing, compare the results of your previous test run on your cloud. So we'll be talking more about all these, especially these 3 projects, what they does, how you can create the environment, how you can run the environment, how you can test your production environment using the parallel run with the different configuration, the different workspace. So to give a brief, this is the OpenStack cloud looks like. So this diagram I especially to bring up like it's based on the interface APIs, and there are different services interacting with each other as well as like with their external interface. So now question comes, what we need to test on this? Like upstream, there are testings there, upstream releases make sure like stability is there. So what I need to test in my production cloud? First is the API, very important. Like you might not directly exposing the OpenStack APIs to your end user. They might use in SDK, dashboard or something, but internally they use the APIs to interact with each of the OpenStack services. So when we release the OpenStack, when we develop the OpenStack, so there might be chance like some of the services, some of the projects have changed their APIs in a backward incompatible way, which can break your production cloud, which can break your end customer using or the OpenStack differently. So as a OpenStack, as a production cloud testing, we have to make sure like whenever you are upgrading or anything, all the APIs are stable, no backward incompatible changes, they are interrupting, everything. Second, like on the right side, role-based access control, like each APIs you can define the policy JSON file, where you can define like the chat string, what user or what role you can give a privacy to. For example, creating a VM, you don't want like any normal user to create the VM on your cloud. You want admin to create the VM on your cloud. So you can control it via RBAC policy files. So same way, you want to make sure like your production cloud, whatever the policy or authorization you have given is not changed. Someone is not making any change or by mistake it is not changed. So that thing you want to test it. Like I have restricted all the users to create VM on my production. So I should be testing those periodically or nightly or hourly basis that okay, no user can access the VM or create the VM. Then upgrade whenever like you go from OpenStack one release to next release. So you want to make sure like everything is being upgraded smoothly. There's everything is in working condition. Service status is very important. Like there are a lot of services for each project. So even for computing, there are 6-7 services available. Even for Swift, there are different services for count, container, and object. So on your cloud, you want to make sure every service is working fine because they can go into a down state, database can be into a different state. So there can be a lot of failure on the services side. And integrated functionality, that's very important. Like many OpenStack projects are related to each other. Whenever you create the VM and attach a volume to that, so you have to create the volume on Cinder side and then attach the volume on no VM. So it involves no Cinder and keystone authorization. If your volume is as an image to VM, it involves Glance and Swift also. So they are integrated functionality in OpenStack, obviously in your production cloud. So you want to make sure those are working fine. How you will test it. Then obviously the non-frequent scenario. For example, sell a VM. So whenever like you have the VM created, you don't want to delete it and re-spin it again. What you want it to do, you can sell the VM, so the image of that VM will be offloaded from your compute node, and whenever you wanted to bring it, you can unsell the VM. So that is not a frequent scenario, that's a very rare scenario. So those scenarios you want to test it. So with all these things, first we'll check with Tempest and Petrol, like what are the testing they can do, what I have discussed in the previous slide, what all area they can test it and how you will test it. So on Tempest side, we have the API test, scenario test, and we have the plugin interface also. Petrol side is API testing, it has the negative and positive test. We will cover like how we do the testing of Petrol with negative and positive scenario. And Petrol cover Nova, Glance, Cinder, Neutron, Keystone as of now. Swift doesn't have policy, so it doesn't cover that. And it doesn't have the plugin interface. So for giving an overview of the gate test, like how much testing we do in the day, and obviously in the production cloud it should be more. So we have different kind of testing, packet code style check we do, unit test we do. So those you can say is more about the coding things. You might not know much care about in production cloud. Fine, but we have the integration test also. So we have around 1,000 plus gate test cycle every working days, and each gate cycle has at least 1,000 plus test cases running. So as a total, it is like 1,000 plus tests running in a day on the day. So that is the upstream testing, right? That's not on the production side. That's not on like in the customer facing side. If something is broken in the upstream, yes, we can fix it next day. But if something is broken on your production cloud, you can lose your customer, right? So you may have to do more and more testing on your production than what we have saw in this case. So yeah, so now on to the Tempest. I'll just give the overview of the Tempest, what is that is new to you. So this is a set of integration tests, and you can run it on your live OpenStack cluster. And it is usually useful for the large number of different environments. Like Gate is one thing we are using as a first use case, but there are many companies that are using in their production cloud. Like AT&T uses it as a very wide range of test cases in Tempest, and there are a lot of other companies using it in their production cloud. And it provides a framework also for writing the Tempest-like test. So it doesn't mean like any other services, or if you have the downstream scenarios, you can write the test in Tempest or not. If not, then you can write the plugin. If it is a very common common testing, you can make it upstream under the QA. If it is a very specific to your production cloud, you can keep the downstream plugin for that. And currently it has API test and scenario test. API test is mainly to verify the backward compatibility of APIs. We have both negative and positive test case, and it's a huge number of test cases. Like we try to cover all possible basic scenarios. It has the smoke testing also. Like if you wanted to run a Tempest on the smoke testing, you don't want to run the complete Tempest, so you can do that. Scenario test is more the integration test, where any test case or any scenario involves more than one service. So those kind of test cases are under the scenario test. For example, I talked about creating and attaching a volume to Nova VM and writing and checking whether the right content is there in the volume or not. So that scenario is there under the scenario test. There are various other scenarios. And we have Tempest plugin. There are currently 59 plugins present. There's a plugin registry document we publish on the Tempest blog, so you can find out the total number of plugins. So we detect it, it's a dynamic live document, so we detect the Tempest plugin using namespace, and whenever there is a new namespace or a new plugin or any plugins you need to do, so that will be updated on this side. So you can see the huge number of 59 plugins are there currently based on the Tempest. And so how you run the Tempest? Like there are two ways. You can run with the dynamic credential or predefined credential. So dynamic credential, I mean you configure Tempest with your admin credentials. That's it. So Tempest will create all the testing project, testing user, testing credential on the runtime, execute the test, and delete those credentials. So that is the dynamic credential. Second way is predefined credential. So in some of the production cloud, you don't have permission to create the resources. And it depends on your backend also. Like for example, if a cloud with Keystone with LDAP backend, you cannot create the user on that. So if any test case, so each test case we run with a set of credentials. So we need the project, we need the user to perform the operation of testing. So if you cannot create the user, you cannot run the Tempest using dynamic credentials. So how you run it. So you can have the predefined test credential, and in the account.yml you can define those credentials. In that way, tempest will use only those defined credentials to execute the test. It will not create any new credential, any new project, new user on your production cloud. So we have tempest conf, where we have a multiple configuration option, like how each services you can configure, what all features are present or not in your cloud you want to test. For example, we have the tempest resize VM test, but resize is not the common feature every production cloud may have. There might be some cloud they don't have resize feature. So in tempest conf you can mention, okay, this resize feature is not present, so whatever the test case doing the resize operation will just skip. And there are various other options in tempest conf. And to make the tempest easy to run, we have created the CLI. I think it's not so clear, but if you just run the tempest help command, you will see all the CLI there. So the key CLI, you can say the tempest runs, so it will run the tempest. You can define the regex set of test case you want to run with tempest. You can define the blacklist, like test case you don't want to run within the tempest run. You can attack the list plugin using plugins. You can clean up the test resources, and the workspace things are there. So this will be more talking about how you can create the multiple workspace, and you can run the multiple tempest with different configuration on single production cloud disk. So that is on tempest side. Now we have Petrol. So Petrol is, as I talked, it's a RBAC testing tool. So it's based on the plugin, tempest plugin, and it also has an integration test to run against the like OpenStack cluster and to check whether your policy or your permission to those API operations working fine or not. For example, same way, like if I have say create volume and only admin can create the volume, so via Petrol you can check whether admin is able to create the volume, and you can check whether non-admin is not able to create the volume. And how you do that? It has a set of configured roles. So on the same Petrol run, you can define the set of roles, like member, reader, admin, non-admin, or some other normal user. And the Petrol test will be running against each roles and will detect like that role should be able to access the operation or not. If there is any mismatch, it will fail the test case. So next slide I will exactly tell how it does. So we'll take example of Noah and create server API. So this is the policy name, like we have our server compute server create. So this is the policy action name, and after that you define the check string. Check string means, for example, admin or owner or any user. So which defines what all roles of that user should be able to create the server node. So if you check this, this is the API compute server. So how Petrol will do? Say this is the role you have configured in the Petrol configuration, role member. So with role member, you want to check whether it is able to create the server or not. So first is Petrol call the OpenStack API with the member role, and it stores the result. Say it passed or failed. This is the API interaction where your end user or SDK or dashboard will interact. Now, how it will verify that result is correct or not? So what we do with the Oslo policy? So Oslo policy is we have a library which check the policies authorization. So what Petrol will do? It will send this member role to the Oslo policy and check whether this rule is able to access this operation or not. So also policy, what it will do, it will check the check string of this policy and it will check against this role. And they can tell if this role has access to that policy or not. And it will give the result. So one way we are directly checking via APIs, other way we are checking via actual Oslo policy enforcement. And we compare both results. If results are mismatched, test will fail. For example, if member is able to create the server, is not able to create the server, so Oslo will say not authorized. And if you access the APIs and it pass, it means something is wrong with your protocol. Your access, your security is being modified by someone. So you can immediately check the policyization file or what went wrong. And so that's the how you can, what's the tempest and patrol is, how you can run it for RBAC testing and integration testing. Now we'll cover the workspace, like how you can run the how you can run the multiple set of tempest run in a different workspace, testing the single production site or multiple production site. So you can do it via workspace. So this is the CLI. You can initialize the workspace. You can give any name. Workspace 1 say cloud 1, cloud 2. So what workspace means is it creates a temporary folder, and under the folder we will have tempest form, we have the log, extension form, log directory and the log directory. So every workspace have their different set of files. So this tempest form you can override with different configuration. This you can override with different configuration. Okay, so and each tempest plugins or patrol, it will be installed in your workspace and you can run the workspace. So when this workspace, when you go inside this workspace and run the tempest, it will use these configuration files. And the second tempest run in parallel, you are running on the workspace too, it will use these configuration files. So if you are for example, if you are testing two production cloud and this one cloud has resize feature enabled, other has resize feature disabled, you don't need to run tempest two times. You can create two workspace, different configuration, run the tempest in parallel. It will give the result of both. So this is how you can create the different workspace and run the tempest. Now, how you can integrate these tooling, testing tooling with your CI/CD Joule. So in Joule V3, I'll take example of Joule V3. So you can add the playbooks to set up and run the tempest or plugins. So setup means you can tell to install tempest and what all plugins you want to install. You can tell what configuration you want for tempest, and running tempest means like creating different workspace or single workspace and running the whole test. Standard setup include the three playbooks in Joule: rerun, run, and post. Rerun is something, the Ansible playbooks you create will be executed before running the test case. So there you can define like creating the directories, giving the permission to that directory, installing stuff like tempest plugin or any other services. And then you have the run playbook. So in that Ansible playbook, or you create the Ansible role, you can define how the tempest should run the test case, what all test case has to be run. And then post run is more about like after test cases are run, how you publish the log, how you want to see the result of test case. And this is the one example of tempest full job we have, which being executed as an integration, gate testing and upstream. So this is the base loop where you can find the pre-run, run, and post-run. If you go to the Tempest repository, so you can find this base definition of that. So otherwise, you can define like these variables, like what POX environment you want to run. POX environment is nothing but installing a set of pre-defined dependency and run the Tempest with Tempest agents. So this kind of integration you can do of these tooling with Zoom Utilizo, and those will automatically execute and give the result of your test case. So next we'll talk about OpenStack help dashboard. Like we have run the Tempest, we have the results, and we can integrate those tests run in the Zoom. But how or the best way to check those results, best way to visualize those results, that is very important because it's a huge data. You cannot manually go and check the subunit stream and check, okay, what all tests been run, fail, pass. So we have created an OpenStack help dashboard. So how it works is like whenever you execute the test case in the subunit stream, every data like the number of test case, mode of test case, the result of test case is present in subunit stream. So that we can pull it via subunit to SQL and store it into a database. And from the subunit to SQL via API server of OpenStack help dashboard, you can visualize the result in a graphical view. So this is not visible. We will show the live result of OpenStack help next. So for example, so we talk about the workspace, right? So how we collect those workspace data. So this is the tooling we have installed, and this plugins, and workspace we have created. So say for example, you have 3 OpenStack sites. So how you will check it? Because as a production, there might be, it's usual like you have different locations, your sites present, you are running or creating the VM. So how you test all these together? So what I created is a cloud health node. So cloud health node is something like especially for testing and monitoring your cloud health, whether it's good or not. So in that cloud health node, what you can do, you install all these Tempest Patrol and the plugins, create the 3 workspace, and each workspace will run the Tempest. Say this workspace 1, it will run the test against OpenStack site 1 and fetch the result. Workspace 2 will test the OpenStack site 2 and fetch the result. So we have 3 Tempest run testing different sites and they have the results. So all these 3 workspace you can integrate via subunit as well in a single OpenStack help dashboard. So there you can check what all test case has been passed, failed, running time or comparison to the previous run, everything you can check via help dashboard. So you don't need to worry about every single Tempest run execute or you need to store where to store the data and all. What you need to do is just check the OpenStack help dashboard and compare the result. For example, if you are running, say the result of yesterday, say 50 test case pass, and if you are running Tempest today and it's saying say 40 test case passed and failed, so you can easily detect like something is wrong from previous time to yesterday to today, right? So you can detect like if any patches is merged in upstream, if you are running master, or any something has been modified on your production cloud which is causing the failure of the test case. Or another example is like whenever you are doing the upgrade. So if you are running on the various OpenStack style, these are my results, 50 test case pass. These features are running fine. I have upgraded my production cloud, now I am running the Tempest. Something is wrong, 40 test case only pass. So there is something has been changed in upstream from style to trend development, which is causing your production cloud testing fail. So with a single health node, with a single health dashboard, you can analyze all these things. And when it comes to the upgrade things, so when your OpenStack site is being upgraded, say from Rocky to Stein, so the health node you don't need to upgrade. Unless you need the new test case or something, update is there in Tempest and you want, that's fine. Otherwise, you don't need to update anything here. With the same configuration, you can run your cloud before and after the upgrade and check whether it's working fine. And you can compare the result with before upgrade test result and after upgrade test result. Because comparing result is not just about pass or fail test case, it's all about like how much time they are taking and what all features are behaving stable or not. Because sometimes when you do the live migration test case, out of 20 run, 15 is pass, 5 is fail. So you cannot say feature is failing, but you can say feature is unstable. So you can analyze like in Rocky, live migration was working fine, but in Stein it's little unstable. So with a single health node, without upgrade, you can identify your cloud. And one more thing on this workspace side. So this is the example of different OpenStack site. But if we take an example of single OpenStack site, so you can still test single OpenStack site with the 3 workspace with different Tempest on and running the Tempest on each workspace. So for example, feature availability is the one thing, like you want your single site or multiple site has different set of features and you want to execute the test case against them. But the next scenario is like, for example, there are different use case of your OpenStack site, different use case of your production cloud. In some use case, you are disabling the access permission. Some use case you are giving the access permission. So how you can test two different configuration or two different use case of your single production cloud. So you can still do it via workspace execution. So this is how OpenStack Health dashboard looks like. So this is a screenshot. I will open up a live dashboard of that. So that dashboard is running on our gate. So every OpenStack, every commit running the set of test case, and we have shown like around more than 1,000 gate cycle is there per day. So we collect. So we collect the data of each run and we show it on the OpenStack Health dashboard. And we make sure like everything is stable or not, it is disabled, it is unstable, feature has been, or some project has been introduced, the backward incompatibility causing the test fail or not, everything you can do it. This one. So this is the job name. So we run the set of tests. Let's say neutron full test. So it will enable the neutron and it will run the complete test case of 10 tests. And these are the projects that showing the status of each node running on the instrument. So OpenStack Nova. What is the current status of that? And if you go on this upper side, these are the total jobs running. Like this time it has around 200 jobs running on that. And these are the jobs failure rate. Like wherever it is failing, it's going up, and you can see the graph of how when the job is failing, when it is stable. And on this side, if you see of a particular job, you can see the status of the test case. So each test case you can see this the peak are like the runtime, how much time the test case is taking, and if it is failing, it will be in the run. So even still it is passing, we can compare the time executed by the test case, which is nothing but the time taken by the operation of that service. Like if I doing the create VM, so in this case, create VM is very small, less time, but at this stage it has takes a lot of time. So something is wrong on the compute side, why it is taking more time to the operation. So not just result pass or fail, but you can still compare the performance of the each API operation and test case. So these are reference. We have the document for Tempest, Patrols, user, and dashboard. And this is the link actually. It linked to the network. But if you click on this link, it will show you the live test result of our gate running around let's say 1 million or 10 million tests, 1 million tests. So you can click on those links, you can see what all test cases are running, failing, passing, taking time, everything you can see on this. It's a live site on the OpenStack. So we have around 2 minutes left. So that's all from my side. I'll open up for question if you have, you can ask.
So I have one question for you. Usually we have the infrastructure of OpenStack with running in production. So every time we deploy something on it, like I said, some complex, we need to test all the functions of the whole system. And we usually use the Rally to deploy. And the question is, how can I use the template for this purpose?
Yeah. So when you run Rally, actually Rally also internally use Tempest, but it does more than that also, like performance and benchmarking testing also. So when you say like whenever you are deploying your specific use case, so you can still run the Tempest, and in the Tempest CLI Tempest run, there is a way you can define the regex of what all test case you want to run, what all test case you want to see. Because if specific things have been changed in your production deployment, you don't want to completely run the Tempest, right? If say quickly you want to check it, you can run just smoke test, or you can run the particular set of test case for that test, and you can check this. So, and if you are doing the changes of your deployment in a parallel, as I mentioned, like with the different workspace, you can run the different set of tests using the Tempest. So that will give you the clear picture. And other thing is like we have set of test case defined, but if you think like some test case are missing, not coming to your scenario, and it makes sense to be tested at upstream, you can always contribute in upstream, or you can tell us like this test case is missing, so we can. But yes, Tempest can be run on that scenario.
So one more question. What is the benefit of benefits of template? Is that what's the benefit of template than the Rally?
Yeah. So so if you say Rally, so Rally has so for the API operation and the integration testing, Rally use the Tempest. Internally they run the Tempest. But they do all other benchmarking tests also. So if you have very specific things to test, you can directly run the Tempest. Because in there you have to set up different configuration and you have to run the complete stack with that. But if you have like the particular things to test, you can still do it directly while the Tempest. So with Tempest you have the different way to configure Tempest, different way to run the Tempest with multiple instances. Visualize your dashboard. So instead of like going from one tooling to internal tooling, it's always good like you can directly use that tooling, like second test and
Okay, thank you.
okay, thanks.